Right, I'm just doing a follow-up on the previous video about this Hewlett-Packard 3330B automatic synthesizer. Raised a couple of questions there. Also, I managed to break my camera by negligently holding the camera and expecting it to support the weight of the tripod, which tore the camera mount out of the bottom of the thing. Now, this model is notorious for this being a weak point, but what I did, I wouldn't expect any camera to be undamaged by, so a moment of thoughtlessness and damage. So I've now ordered a new mount which grips the lens body, stronger support, and while I'm waiting for that to come, I've just knocked up a wooden facsimile which looks like this, and now I'm using it. Good enough for the moment. Didn't even bother painting it because it's very interim measure. Right, this 3330, so I was wondering in the previous video if this reference tune adjustment, which I'd completely forgotten about, might affect an issue I was seeing, which when I first did it seemed to be a constant 20 megahertz higher output than what was programmed in on the front panel. But in the last video we saw that it wasn't quite that. It was constant 20 megahertz plus a bit depending on the output frequency. Anyway, but both could be explained by if the reference oscillator was out by about 20 hertz. And I did play with these and didn't get much joy. There's this paragraph here which I have read multiple times and I'm still not sure what it says. Not helped by the fact that it's squashed into a small column. But when I did play with this, I found that this had no effect while it was set to the internal position, which is what I would have expected it would have its effect, but when I turned it to external, I could get a slight change in the output frequency, and turning it off, in fact, is where it produced the most accurate output. If it's on external and you're not tuning it, and you're not sticking an external reference in here, what the hell is it using for a clock? I don't know. And this paragraph didn't help. Anyway, I thought I'd go through the adjustment procedures. I won't go through that in detail in this video. I'll just check these and see if I can find anything that stands out. There's a reference oscillator adjustment section, so that could be interesting. Also interesting is there's this ref tune input, which apparently is a voltage control of the oscillator over a very narrow range, so that could be used as a input control from a GPS to make this into a GPS DO. There's a couple of different methods, but anyway, a correction voltage can go in here to adjust that oscillator to produce precisely the right output. Yeah, that's interesting. It could perhaps build in the extras needed to make this into a GPS DO. We've got a couple of free holes to mount an SMA connection for an antenna. Worth thinking about. Anyway, I'll go for this lot. I won't do it on video, just unless I find something interesting. So I've checked the power supplies. They're all very well within spec, within 10th of a volt. Measured the ripple across all these capacitors, negligible, so I'm pretty sure the power supply is fine. And this adjustment procedure has you switch it to external, measure 1 megahertz coming out of that, and adjusting. You might remember there was a proper air vane trimmer capacitor in there, and I could adjust that and get 1.0000 megahertz on the oscilloscope, fine there. And then they say to switch it to internal and adjust this to get 1.00, and I couldn't. It did almost nothing, and it wouldn't bring it down. It was still 1.003 or 20 or 30 hertz too high. So that smells like the rat. It doesn't say what to do if that's not the case. I have to go into the troubleshooting procedures to sort that one out, but that's for another time. So yeah, that's where we are with this thing. Probably that needs looking at, the reference oscillator. Hope you enjoyed that. Catch you later.